What's going on, guys? In this video we are going to see how to solve this second order non-homogeneous differential equation using various parameters. Okay, the first thing is we have to find out the complementary solution, and then we have to find out the particular solution, because the general solution of the differential equation is going to be addition of complementary solution plus particular solution, yp. Okay, now let's see how to find out the complementary solution. To find the complementary solution, what we do is we equate the first term to 0. Y double prime plus y is equal to 0, and make sure it should be in standard form. If there's something here, you have to divide everything by that and then bring it into this pattern. Okay, now y double prime plus y is equal to 0. Now we have to write the characteristic equation for this one. That's going to be just m square plus, since we don't have y prime, this is going to be just the value in front of this, that's 1. Okay, and that's equal to 0. And here we are getting complex number, because this is going to be, m is going to be equal to plus or minus I. Okay, the coefficient of I is 1. Here we don't have any real number, we have the imaginary number, that's just 1. Therefore the complementary solution is going to be this. Yc is equal to e power, we don't have any real number, so e power 0 times x, it means that's going to be just 1. We can neglect that. And then we are going to have cos x and sin x, c1 cos, and the imaginary part is just 1, so this is going to be just 1x plus c2 sin x. This is our complementary solution. Now the next thing is we have to find out the particular solution. To find out the particular solution, we have to figure out what is y1 and y2. y1 is this one, the first one is y1, and this is our y2. y1 is equal to cos x, y2 is equal to sin x. Now to find out the particular solution, this is the format. Yp is equal to u1 times y1 plus u2 times y2. Now here we have u1 and u2 known already. This is, y1 and y2 is known already. y1 is here and y2 is here. We just have to figure out what is u1 and u2. To find out u1 and u2, we use this equation. u1 prime is equal to w1 over w, u2 prime is equal to w2 over w. This w1, w2 we had to find out using Wronskian. Now after we find out this equation, we had to integrate this one, because we had to find out what is u1 and u2. Here we have u1 prime and u2 prime. After we find out this one, we had to integrate. Now let's go ahead and find out w, w1 and w2 first. To find out w, what we do is we pick up this y1 and y2. y1 is cos x, we put it in 2 by 2 matrix. y1 is cos x, y2 is sin x, y2 is sin x, and then we have to find the derivative of this one. If you take the derivative of cos x, that's going to be minus sin x, and if you take the derivative of sin x, that's going to be just cos x. Then we have to find the determinant of this one. Determinant is ad, like this one multiplied by this, cos square x minus sin x times minus sin x, that's minus sin square x, minus become plus, so sin square x. Here we have cos square x plus sin square x, this is going to be just 1. Okay, after we find out Wronskian, now we have to find out w1 and w2. When we find out w1, what we do is this one represents, like when you see 1, you can remember you put first term 0. Okay, the second term remains the same, sin x. And for the first term, below the first term, what you do is we put the g of x. This is our g of x. Whatever the value comes after equal sign, that's our g of x. That's what we had to put it under 0. That is tan t in our case. But let's put tan x, because we are keeping everything in terms of x. Let's change this equation into x, because I should have put everything in terms of t, but I made a mistake putting as x, but I changed the equation as x. Now it's correct. Okay, now this should be tan x, and here derivative of sin x, that's going to be cos x. Now again we have to find out the determinant. ad, like this one times this, 0 times cos x, that's 0, minus tan x times sin x, that's going to be just sin x times tan x. Okay, so we can write minus sin x tan x. Now we have to find out w2. What we do is instead of putting like this, here we have 0 in the first place, now we have the 0 in the second one. Okay, and we have the g of x in the second one, tan x here, and then we keep the first term. This is cos x and sine minus sine x, cos x and the derivative of cos x, that's minus sine x. And then here again you find the determinant, cos x times tan x, cos x. I expand this tan x as sine x over cos x, so you can cancel this cos x and cos x. Finally we will get sine x, because this one is 0, minus 0, we don't have to write it. Okay, minus 0, that is equal to sine x. Now we have found out w1, that is this one. We have w2, we have w, so we can find out u1 prime and u2 prime. Okay, let's go ahead and find those things. u1 prime is equal to w1 over w. w1 is minus sine x tan x, minus sine x tan x. Now we have to integrate this one to find out u1, because in particular solution we had to have u1 times y1 plus u2 times y2. So whenever we have u1 prime, we have to find the derivative, integral of this one to get rid of this derivative u1 prime. Okay, to find u1 we integrate this one, but the easier way to integrate is you have to change the form, like minus sine x. Instead of tan x, I put sine x over cos x, because if you expand tan x, that's sine x over cos x. Now this is going to be minus sine square x divided by cos x. Then instead of sine square x, we can replace that one with 1 minus cos square x, because if we bring it in this form, it's easy to integrate. And 1 over cos x, that's sec x minus sec x, or we can just put the sec x last, because this is going to become plus cos x minus sec x. Okay, 1 over cos, that is sec x. Now we are going to integrate this one. If you integrate u1, let's integrate sine with respect to x, this one is x, with respect to x. If you integrate cos x minus sec x, you will end up with sine x minus ln of, okay, let me have some space. Let me begin from here. I'm writing the integration of this one, that is sine x minus ln sec x plus tan x. This is the integration of this one, and that is equal to u1. If you integrate u1 prime, that's going to become u1. This is one of the important solution. And then now we have to find out what is u2 is. u2 prime is equal to w2 over w. w2 is sine x over w is 1 sine x, and if you integrate sine x, that's going to be negative cos x. So u2 is equal to negative cos x. Okay, now we have u1 and u2. Finally we have to find out the particular solution. Okay, now I get rid of all these wrong secant things, because we found out u1 and u2. That's the purpose of this wrong secant. Let's get rid of these things. Okay, 1 second, I get rid of these things. Okay, let me write the particular solution. Yp is going to be u1 times y1. This is u1 times y1. u1 is sine x minus ln sec x plus tan x, and y1 is cos x. Here is our y1. Okay, cos x multiplied by this sine x cos x minus cos x times ln sec x plus tan x. Okay, then okay, now we have u1 times y1, we just did u1 times y1, then u2 times y2. u2 is minus cos x times y2 is sine x, so minus cos x sine x. Now here you can notice one thing, that is sin x cos x minus cos x sin x, same thing. Here we have plus minus, we can cancel each other and we will end up with this one. Okay, we have particular solution that's equal to minus cos x times ln sec x, not sex, sec x plus tan x. Okay, now we have the particular solution. Now the next thing is we have to add this one with complementary solution, yc plus yp. Complementary solution is already here, so we can write our general solution for this differential equation. That's going to be y is equal to c1 cos x plus c2 sin x minus cos x ln of sec x plus tan x. Okay, that's it. This is our general solution for this second order non-homogeneous differential equation. I hope this helps. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.